So we can start the live code walkthrough, and I'll quickly share my screen. So in this session, we'll be having a Micronaut application. So Micronaut is similar to Spring Boot framework. So Micronaut is also a framework for building web APIs. So if you have any queries regarding Micronaut, you can search that or post the question in Q&A. So we have created a template, simple template of the Micronaut using CLI. And here we'll start looking down each and every file what we have created here. So we'll start with build Gradle. We have used Gradle for this, and let's see what are the dependencies that this application needs. So first one is the Micronaut GraphQL. So here we can see that all the GraphQL dependencies that we need to build the GraphQL application. So this will be covering in this dependency. And then above that, so in the earlier talk, we learned that there are two approaches, code first and schema first. So in this uh, coding session, we'll be using code first approach. So we'll be writing down all the code and the schema will be generated through the library. So in this case, we'll use LeanGen speaker library. You can search about it later, and you can also post down on the Q&A to learn more about it. So we'll use a LeanGen for generating the schema out of the code. So the all other dependencies that are listed down here are used by the Micronaut or the internal framework that it needs. So we just want to know more about these one. So this one is for the GraphQL and this one is for creating the schema out of our code. So let's go down to the go up to the source code. So source main, and inside the Java we have the source code. And first package is the GraphQL. So in here we have a GraphQL factory that is responsible to configure the GraphQL. And then we have a custom annotation. We'll get into this after covering all those packages. In the handlers, we have different handlers to handle the GraphQL APIs. And then we have models. Inside the model, we have user and address. So we'll be taking the same example. So we have a simple use case to get all the users, and we'll be creating a user. So this will be our use case. And inside the resolvers, we'll be creating resolvers. And inside the services, there will be services. And then this is the application. So this is the bootstrapped application. So if you have worked upon the Spring Boot, then the application will be bootstrapped and will be run. And the server will be spinned up and your beans will be created. So this class is responsible for that, the main application. And inside the resources, we have the properties file. So in the application YAML, you can give your name to your application and what port you want to spin up your server, and the endpoint that you want to expose to clients to reach out to your server. And then we have the playground. So this playground is used to test our queries or mutations. We learned about the queries or mutations. So we can test it out on this endpoint. So we'll look upon it as well when we'll create query and mutation. So let's go to GraphQL factory, what it has. So GraphQL factory is responsible to create a GraphQL bean. And here we'll tell how to generate the schema and how to scan our classes and generate schema out of it. So let's see. First, there's a GraphQL schema generator. So in the we can see from where it is coming. So GraphQL schema generator is coming from LeanGen that we have defined in Gradle, build Gradle, that external dependency. So here we are telling that the base package is com ThoughtWorks GraphQL. So we can see that this is our base package, and we'll need all the classes inside this. And then we are also qualifying all the classes that have this dependency, this annotation, GraphQL resolver. So we have created this new annotation, and we'll be identifying each and every resolver through this annotation. So we'll be covering this in a later point of time. You will get a clearer picture after we have created first resolver. And then we'll have all the resolvers inside this collection, and we'll iterate it over the collection and register that class inside the schema generator so that it can get to know that these are my resolvers. And then after that, in the execution strategy, we tell that this is my exception handler. So if we want to handle exceptions globally or in a generic fashion, then we can handle the exceptions here. And then at the end, we generate our schema generator.generate. And inside that, for the queries and mutations, we tell the execution strategy, and so that we can handle our exceptions. So after this one, GraphQL resolver, this is our custom annotation. And then in the handlers, we have talked about the exception handler. This is the exception handler. And then we have pre-parsed document provider. So this is the document provider. This is used to cache the queries or to validate the queries. So we have used it when we are configuring GraphQL bean. So here we have used it. And then we have talked about the user. So user, this is the GraphQL type. So as we have seen that this is the object type. So in the schema, there were many types like scalar or object type or the enumeration. So this is the object type, and we'll be using this to get the user or to create the user. So let's start with the first resolver. Let's create first resolver. So this will be a Java class and it will be named user resolver. And we have to identify it as a resolver. So we'll annotate it with GraphQL resolver. And then inside that, so the first API will be creating query, and this query will return me all the list of users that are available. So let's have a API for this. List of users, and name would be get users. And inside this will be returning all the users. So to return the users, we can create a service for this that will be a user service, and it will be returning us all the available users. So let's create user service, and this will be a singleton. So this annotation is to create a singleton bean inside the container. So if you have worked upon Spring Boot, then you might be aware of these different stereotypes. So this is equivalent to those stereotypes, or you can post a question on Q&A if you have any questions regarding it. So we'll have a simple function that will return us all the users. For this use case, we'll have in-memory users that will return us the users, or we can also connect to DB or call any third-party API REST service to get the users. So we'll have a in-memory users here, public static list of users. And we'll initialize it. And we'll add one or two items. We'll add one item here. So we'll take the implementation of the array list of the user, and we'll add one item inside it so that we can see it in the query. So we'll use builder pattern for this to build the user, and we'll set some of the fields here like ID, and then we can set the name as well. And we'll return the same list inside this users. And now we can use the same service inside our resolver to return our all the users that we have. So we'll inject this user service, and inject is equivalent to auto wiring in Spring Boot. So we'll inject the user service inside this, and we'll return user service.get users. So this should return all the users that we have in user service. So let's run this application. So this will bootstrap our application and we'll spin up the server. And then we can go to our endpoint that we have defined in application YAML properties file. And this is the GraphQL playground. And here you can see that we have a documentation explorer. So we can see all our schema here. So inside the query, we can see, let me just refresh this. So here we can see that, okay, so there is a miss. So GraphQL doesn't know that whether this is a query or not. To identify whether this is a query, or mutation, you have to tell that this is the query and you have to give its name as well. So we'll name this as users and we'll restart the server. Okay, and let's see. Now inside the users, we can get list of user. So let's write this query. So we want, this is the name, get users, and inside that control space will give you freedom to get the auto suggestions. So this is the query that is available, and inside that we can tell whatever we want. So that is the specialty of the GraphQL. So the client can tell what all the fields that he is interested in. Okay, so we do not have any parameters, so we do not need to pass any parentheses. So we can see that we are getting the data, list of users. So this is the simple use case of getting the data through query resolver. So let's get down to mutation. So mutation is to create the data, or if you want to update some data. So we'll create a new user. So we'll have a mutation for that. So let's see how to create a mutation. So let's write it down. So we'll be returning user, the created user, and the name would be create user. And we have to pass the user from the client. So for that, we will have a annotation as GraphQL argument, and we have to name it as well. What will be the parameter? And then we can specify user, and it will be autofilled. And now we want, in this use case, we'll be adding the same user in this list, and we'll be returning all the list in the get users. So we'll write down a method for create user in the service, and we'll return the same user, create user, and that will be the same user will be passing on to this, and we'll add the same user in our list, add user, and we'll return the same user. So here we can have a DB to save the user, and then we'll be returning out of it. But for this demo, we'll just have an in-memory list. So we can use the same method in the resolver. So we'll return user service dot create user, and we'll passing on the same user that we received from client. And we have to tell that this is the GraphQL mutation. So now it will identify that create user, this is the mutation. I have to create mutation out of it. And moreover, so we have learned in the previous talks that we can have a validation in the object types. So if you want that this created user shouldn't be null, then we can add annotation that is GraphQL non-null. So that will ensure that this user will not be null. Otherwise it will give error. So we can restart our server and check the mutation that is being created. So the server is up. Now we can go to 1001 graphical playground, and we'll write down mutation for this. Okay. First of all, we'll check whether this mutation is available. So we can see that create user mutation is there. And inside that, these are the variables that it accepts. So inside this, we have seen earlier in the schema. So something similar kind of stuff was there. Email, ID, and name. This is the object type. And here we can see that what it is returning user that is not. So that ensures that this user will not be null. So we'll write down the mutation for this. So we have to write down mutation and the name of the mutation. This could be anything. And we have to pass the user from query variables. So here we can specify the query variables as well. So we'll pass down the user, and that is similar user input. And here we can control space and see create user is autofilled, and we have to pass down the user in this mutation. user, and we'll need something. So it is returning user. So maybe we can check what is the name of the created user. Now we have to pass our query variables. So here you can just press Control Tab and all the auto suggestions will be there. So we have to pass down user. This is the object, and then we can pass email, and we can fill some of the details here. And what is left? Okay, so this. So the user is being created. We can also verify it by fetching all the users. So we should see now 2 users. So first entry is this, and second one that we have just created. So this is the way we can create mutation. And now we can also check how we can test this functionality. And we can have unit test as well and integration test as well. For the unit test, we can just simply write down the JUnit test for this. And we have tested user resolver, and that is the get users inside the user resolver. So what we can do in the unit test, mock down all the dependencies that we have inside the user resolver. So dependency was the user service. So mock the user service and test the actual functionality of the get users. So we have mocked it and returning the pre-populated user. So this is the constructed here in the before each. And then we are asserting the same user, whether we are getting that object or not. So this is simple as JUnit test. And for the integration test, we can use HTTP client for that. So if you have seen, if we are using the playground, so whenever we hit the run button, so what it does is it creates a HTTP request that is post, and the endpoint is /GraphQL, and it is giving the payload of the request is having query, operation name, and the variables. So we can pass down all the required parameters in the test itself, and we can assert the response that we got. So here in the test, we have used HTTP client to make the HTTP request. And then in the request, we tell that for the payload, you have to use this JSON. So in the JSON, we have list down all the query that we want to test. And then in the response, we asserted through the file that the actual response should match this response. So in this way, you can write down your integration test as well. So this is the way you can create queries and mutations. And further down, you can also create field resolvers, and that will be taken care by Akshay. So Akshay, you can start.
Cool. Thanks, Shubham. And hi, everyone. My name is Akshay, and I'm working as the application developer in ThoughtWorks. So the next thing we will cover is field resolver. So I'll just share my screen first. I hope my voice is clear and audible to everyone.
Yeah, Akshay.
Okay, cool. Thank you. So as Shubham explained that how you can create resolvers and how you can fetch the data and mutate the data for user, right? So we'll take another example where we will fetch different fields for user, and we'll see how we can fetch and resolve a specific field in user data, right? So I'll start the server first, and we'll see into the existing query and what changes we want to make to fetch another data in user type. So if I look into the documentation here in the root query, I can see currently I can fetch the users list, and the type, if I check, I can fetch for name, ID, and email currently, right? So if I take an example of a real application, there can be scenario that your data for your user data is coming from different sources. For example, name and ID and email are coming from service one, and say there is another field, say address, which is coming from service two, right? that is a very generic scenario. So we'll take that scenario and we'll implement that to look into field resolvers. So if we see what our query will look like when we say we also want to fetch address for each user. So the query will say that I want to fetch all the users, and in the users I want to fetch name, say, and I also want to fetch address, right? And say address contains city and street for now, right? So this is what the query will look like. And if I just run this query, I'll get the error saying that address field is not defined on the user type. That is something which we have seen in the documentation also, right? So we need to fix this first, right? So what we're going to do, we'll go to the code. And one thing we know that our address is coming from different service. So first thing we will do is we'll create a new service here, and we'll name it address service. And we'll add the annotation singleton so that we can inject it in our resolver. And there will be a method which will just provide us the address, right? And the name can be address, get address. We know that address is associated with the user, so we need some unique identifier to get the address. So here we will just take user ID. So currently we will not use this user ID, we'll just return a dummy data just for checking. So we will use the builder pattern again, and if I check in address, we have in the address model we have street and city here only, right? So I'll name the city as Gurgaon and street name as street 32, say, right? So now this address service is providing me a dummy data, right? So now we will see how we can use this service in our user resolver to resolve the address for each user, right? So if I see this method here, which is resolving all the users, I can see that this is using user service, which will not provide me uh, the address, right? That is only provide me the email ID and name of user, right? So what we're going to do, we'll write a separate resolver that will be the field resolver, and that will be responsible to resolve the address for each user, right? So we'll write resolver which will return the address, and the name can be get user address, right? And here we need to use the address service, so we will inject that, right? Now we can use that address service in our resolver. So I'll say get address, and we know that it will take a unique identifier. For now we'll just hard code it, but we'll see how we can pass a actual user ID from here, right? So let's see if we rerun the server, let's see what changes. But before that, we also want to say that this is a query, right? So I'll say this is a GraphQL query and the name is address. And we can add some description also, say user address, right? So let's restart the server and let's see what changes we can see in the documentation. Now, if I look into the query here, I can see there is a new field which has been added, which is address. That means I can now query for address also. But if I see there is no association with between address and user type, right? I cannot say that user has a address field or address belongs to user, right? And even if I check the user type here, the return type of users list, there is no address field. So I cannot get the address for each user. Even if I run the query, I'll get the same error, right? That the address is not defined on the user type. So any guesses how we can achieve that, how we can indicate GraphQL to say that address belongs to user? Anyone want to try in the chat box? Okay, so there is an annotation where someone has given accept address as a argument in query. Okay, so you are saying that we already passing that as a uh, as a request in the query itself, right? Okay, so for that, right? So what we have to do, this is a field resolver, as you said, right? But this field need to be resolved for a specific type, right? This need to be associated with some type, right? So for that, there is a annotation which GraphQL provides, which you can use, which is GraphQL context here, right? And we can say that this address field belongs to user context, right? And we will also get the user object here, which we can use and get the user ID, which we can pass in the get address. So we can just say user.get ID, right? So we'll run the server again and we'll see what changes we can see. We'll look into that, what this GraphQL context is doing here. But before that, just let's rerun the server and see whether it is working or not. Now, if I look into the query in the documentation, as you can see, there is no address field which is present now, that has been removed. But if I check the return type of this user, which is a user type list, right? If I look into that type, I can see there is a address field which has been added, right? And that is one of the benefit which we get in the code first approach, because this schema is defined uh, by the package which we are using underneath. So we do not have to maintain it separately. My resolvers are creating that schema automatically, right? Whatever we are writing in our resolvers, that is creating the schema out of it. So if we run the schema here, if we run the query here, I can see that we are getting the address also, right, for each user, which is good, right? But now let's see what this GraphQL context is doing here, right? So to understand that, I have a simple tree diagram which we can use to see how the query is resolved in GraphQL. So I hope everyone can see this diagram. So what we are doing here is we are making a query from the playground, right? And we know that we are making a query to fetch the data for all the users, right? And that will be resolved by our user resolver, right? And the user resolver is using the user service underneath, right? Which will provide us the data for each user, right? But that will not provide us the address, that we know, right? So while resolving each user, uh, GraphQL will check whether it's getting all the data which has been asked by the user or not, right? In this case, from the client side, ID, name, and address has been asked, right? But we know that user service will only be able to provide us the ID and name, that will not provide the address. So in that case, for each user, GraphQL will try to search for address resolver in user context, right? And once that has been found, address will be resolved by that resolver, right? And all the underneath field in that, and that will be done for each user which has been asked, right? In this case, we are asking for the complete list, so for each user, address will be resolved at a time, right? And this thing will happen in parallel, so this will not be in a sequence, so there will be no waiting time for each user, right? If I go back to the code now you can understand that why we are getting the address for each user right here, despite we haven't created a field in the user type, right? So the next thing we will look into, which Abhishek already talked in his uh, session, that we will also get uh, partial data and partial error in some cases when there is any error in one or two underneath APIs, right? So let's take the same diagram to understand that. So let's say we are fetching for all the users here, and say for user one, there is some issue in the address resolver, and this resolver failed to fetch the data and it throw the error, right? But for user two, the address resolver is success and it provided the address for user two, right? In that case, what is the expectation that for user one we will get the error uh, for uh, for the address resolver, and for user two we will get the proper error, right? So to achieve that, to replicate that scenario, what we are going to do here is we'll go to the address service, because that is where the error will be thrown. And I will just add a condition here, which will check for the user ID. So we know that we need to throw the error for user one, right? So I'll just check the user ID here, and I will match it with the ID one. And if the ID is one, then I will throw the error, and that will be say runtime exception, right? And for all the other user, we will just provide the same data. Now if I rerun the server, let's see if that is working or not. So now if I run the server, now you can see that we are getting the error, but we are also getting the data here, right? And you can see that for user 0, that is the user 1, we the server failed to fetch the address, but for user 2, we are getting the error. We are getting the data with address field also, right? So that is how GraphQL provides the partial error and partial data, right? Cool. That's really good, right? And this playground is really beneficial to quickly check or debug uh, the queries which you are creating, or check the resolvers which you are writing, right? But at the end, we will be using this GraphQL API on the front end side, right? It can be your mobile application or web application or a desktop application, right? So we next thing we will look into is how we can fetch the data from the front end, and how we can display it on the UI, right? So what we're going to do here, I'll just remove this error condition so that we will get the proper data, and I will restart the server. If I run, we are getting the data only, right? So now what we are going to do, we'll create a simple HTML page. So we'll add the template, and I have a empty body here. So we will add a div here with the ID, say content, right? And that will be empty div. And we also want to add a script here, right? And that the type will be JavaScript, and the source will be say index.js, right? And this index.js is empty right now. So we will write some code here to fetch the to make a API call on the GraphQL server and to fetch the user data, right? So I will add a event listener here, and we will wait for page load. And once the page is loaded, we will make the API call, right? So we will use fetch to make the API call, and we will hit the local host and the port number and the GraphQL path, right? We'll pass some configuration in that. Those will be straightforward. The method name that will be post and headers. So in this case, we will just have content type, and the content type will be application JSON only, right? And we will also pass the body, which will contain the actual query, right? We'll write the body content on the top, and this body will contain the query here, right? That will be a string. So here we want to fetch, we want to make a query for all the users, and in user I want to fetch name, email, and address, right? And for address, I want to get the ID and city and street, right? So I'll just use async await to wait for the response here. And we will get the JSON content out of it. Right. And once we get the JSON content, we can just show it on the HTML page in the div which we have created with the ID content, right? So we will get the element by ID, and the ID will be content, and we can set the inner text for that, right? And that will be JSON dot stringify of response JSON, right? And we also need to stringify this body content also, which we are passing. Cool. So let's render this page and see if we are getting the data or not. So yeah, as you can see, we are getting the data from the API. I'll just restart. I'll just run it again so that we can see it in the network tab also. So as you can see, there is a GraphQL hit which has been made, and in the content we have got the data with all the users. Cool. So this is how you can make the API calls to GraphQL server from the front end, and fetch the data, mutate, or play around with it. So cool. That's all from my side. The next thing which we will look into is what tools we can use which are in the GraphQL ecosystem.